In this video, we're going to review everything we talked about with domain and range and then work on some practice problems. So remember that domain is the input, x values, or the independent variable in a situation. Range is the output, y values, or the dependent variable in a situation. Remember that when you're describing the domain and range of real-life application problems, you have to think about what values make sense given the context of the problem. So let's talk about this example. The total cost in dollars to buy hats for the players on a baseball team can be found using the function C equals 24.50h plus 40, where h is the number of hats purchased. If there are at least 9 players on a team, but not more than 12, what is the domain of the function for this situation? So let's look at important information. So we have this function. It tells us h is the number of hats, and there are at least 9 players on a team, but not more than 12. And we're trying to find the domain. So remember that the domain is the input variable. So if we look at this function, we have 2 variables, right? We have C, which is the cost, and H, which is the hat. So we know that H is going to be our input. So that is going to be what's telling us our domain. So let's think about this. Now we have to figure out if this is discrete or continuous. Well, if we're buying hats for players on a team, you can't have half a hat or 1/5 of a hat, right? So hats is going to be discrete. So we know that our domain is going to be written as a list. So we're buying hats for players, okay? So the smallest number of players is 9. So the least number of hats that we'll need is 9 hats. Then we'll need any number of hats up to 12, because 12 is our upper limit. So we need 9, 10, 11, or 12 hats, and that is our domain. So Christina's working on finishing an essay for her English class. The graph shows how many pages she has written after spending X hours writing. What is the range of the function for this situation? So she's spending X hours writing, and we're trying to find the range. So let's look at this graph. So it starts off here at 3. So remember that our range is going to be found by looking at the lowest to the highest point. Okay, so I'm going to draw this line right here at 3 because that is my lowest value in the range. Now let me try finding the highest value. Well, I can't, right? Because if I look for the highest value, this arrow tells me this graph goes on forever. So there's really no highest value in the range. So when I write the range, I'm going to write the lowest value, which is 3. And then it's included, so I write less than or equal to y. And then I don't have an upper limit, so I don't write anything else. I can leave my inequality like this, or I can flip it and write it as y is greater than or equal to 3. So let's try this problem. Student council is hosting a party at the local amusement park. There are 5 members in student council, and at least 2 members plan to attend the party. There's a group admission fee of $25 plus $6.25 per person in the group. If X student council members attend the party, the total cost of admission can be represented by f of x equals 6.25x plus 25. What is the range of the function for this situation? So let's find all the important information here. So there are 5 members in student council, and at least 2 plan to attend. The admission fee is $25 plus $6.25 per person. X members will attend the party, and then we have this function f of x equals 625x plus 25. And we're trying to find the range. So we have 2 variables. We have x, and then we have f of x. So x is the number of members, which is the input. F of x is the cost, which is the output. Okay, remember the output variable is what's going to tell me my range. So let's think about if this function is going to be discrete or continuous. Well, we're talking about X number of members. When we talk about members, you can't have half a student council member or 1/4 of a student council member. So this is going to be a discrete function. So we're going to have to make a list. So we're going to have to find the f of x values that work with the x values that are in our domain. Okay, so actually to figure out the range, we're going to actually have to write the domain first, even though the problem doesn't ask us for it. So when we write the domain, The lowest number of student council members we can have is 2, right? Because at least 2 attend. Then we can have 3, 4, or 5 members. Now let's work on figuring out the range values that work with each of these domain values. So let's start off with f of 2. And we're going to plug into this function right here. So we have f of 2 is 6.25 times 2 plus 25. So you can do that on your calculator and you should get that's $37.50. So that will be the first value in our range. Then we have f of 3. So that's $6.25 times 3 plus 25. And that will be $43.75. So that is our second value in the range. F of 4 is going to be $6.25 times 4 plus 25. So when you do that in your calculator, you should get 50. And then we have f of 5, which is $6.25 times 5 plus 25. And when you do that, you should get $56.25. So all of these values are the numbers in the range of this function. So here's a graph. It says the graph of part of a linear function g is shown on the grid. Find the domain and range. Remember, the domain is the x values, range is the y values. So to find domain, I'm going to go from left to right. Okay, and I draw in these lines to help me out. So in the left value, I write -2 because that's my leftmost point. It's not included because I have an open circle there, so I write less than, and I'm talking about x. My rightmost value is x equals 2. I have a filled in circle there, so I'm going to write less than or equal to. Now let's talk about the range. Range is going to go from lowest to highest. So the lowest point is going to be right here at -4. It's not included, so I'm going to put a less than sign because I have an open circle there, and I'm going to write y. The highest value in the range is here at 4. That value is included, so I'm going to write a less than or equal to sign. So in this function, the domain is once again going to go left to right. So if I draw in this line here, that is my leftmost point, and this line is my rightmost point. So the domain is going to start off at -2. The open circle means it's not included, and I'm talking about x. My rightmost value is 2. Once again, I have an open circle, so I put the less than sign. Range is going to go from low to high. So the lowest point is right here, and the highest point is right here. The lowest value is going to be at 2. There's no open circle there, so I'm going to include that value, and then I'm going to write y. The highest value is at 4. There are 2 points that are at 4, but both of those points are open circles. So that means I'm going to write 4, but I'm not going to include it. So here's a linear function. So this linear function, let's describe the domain and range. Well, this is a linear function that goes on forever, right? We have the arrows at both endpoints. Remember, that means that the domain will be all real numbers, and the range will be all real numbers, because there's no leftmost or rightmost point, and there is no highest or lowest point. This graph will go on forever. Here's a quadratic function. So when we're talking about the domain, remember this goes on forever in the left and right direction. So there's no left and right boundaries. So the domain will be all real numbers. If we're talking about the range, let's figure out, let's see, this is the lowest point, but once again, there's no highest point, right? Because in the upper direction, it just keeps going on forever. So I would write -3, it is included, so -3 less than or equal to y, or you can flip it and write it as y is greater than to equal to -3. So let's describe the domain and range of the function pictured in this graph. So if we look at this function, the leftmost point is here at 6, and there is no rightmost point, right? Because this graph just keeps going forever to the right. So I'm just going to write that one endpoint. So I have 6. It is included, so 6 less than or equal to x, which I can also write as x is greater than or equal to 6. The range is going to go low to high, so if I draw in a line, -4 is the lowest point. It is included, and there is no upper point, right? Because it just keeps going forever in the upper direction. So I can leave it as -4 less than or equal to y, or I can write y is greater than or equal to -4. So in summary, remember that the domain is the input, x values or the independent variable, and range is the output, y values or the dependent variable. In a real-life situation, think about what values for domain and range make sense given the context of the problem.